Okay, for this next video, what we'd like to do is look at page 65. So if you look at page 65, this is another torque relationship. And you'll notice it says that we have 6 platforms below or initially at rest in deep space. The indicated forces act on the platform at their endpoints, quarter points, or midpoints. All the forces have the same magnitude. And what they want us to rank is these platforms on the basis of the torque that acts on them, measuring about their center of mass. So that's important. Let the clockwise direction be positive and rank positive torques as larger than negative torques. So let's start off and let's say here is platform A. And on platform A, we notice that there is a force going up at the quarter point and a force going up at the, say, 3/4 points. And remember, the pivot is in the middle at its center of mass. So that means that the distance from this force to here is a quarter of the length of the entire platform. And this will be a quarter of the length of the entire platform as measured from the center of mass to these forces. So we'll call this force 1 and force 2 just to have a way of discussing it. So now when we get ready to calculate the net torque, then what we're looking at is that force 1 is going to tend to cause a clockwise rotation. Force 2 is going to tend to cause a counterclockwise rotation. So when we set up the torque, we're going to say that, okay, so force 2 is going to be distance, or what we call R, times force. And notice that, again, all these are at right angles, so we don't have to worry about the sine of theta. So its torque is going to be 1/4 L times F2. The other force, because it's clockwise, we'll now make this minus. It's going to be distance 1/4 L times F1. And since the forces are the same, then these are going to exactly subtract out, and we're going to get no net torque for platform A. If we look at platform B now, platform B shows that the forces are now moved to the ends of the platform. And again, you could probably look at this and say that, well, you know, that force here is going to, the torque created here, because these distances are both 1/2 L, and the forces are the same, and this sets up a clockwise rotation, and this sets up a counterclockwise rotation about this pivot point. Then you could pretty much guess that these torques are going to negate each other. But let's go ahead and calculate it. So my counterclockwise torque, distance of 1/2 L, force, which we're just going to start calling F because the forces are equal. And then minus the clockwise torque, 1/2 L times F, and we can see those subtract out, and there's no net torque here as well. So if we now look at platform C, then the drawing for C shows, probably should move this over here. We have a force going up at the midpoint, and then we have a force going up at the 3/4 point. And again, we're putting the pivot right here. So now notice that if you put a force going to the pivot, there's no R, so there's no torque created by this force. But there is a torque created by this force, and since it's going to create a counterclockwise torque. So my net torque here is that this is going to be a distance of L/4 times the force F, and this has no torque, whether it's negative or positive, doesn't matter. So my total torque is L/4L. All right, and then platform D, we have again one of the forces going through the midpoint, and then this time we're going to put the other force through the end point. So it's a distance of L/2 away from the pivot. So again, when we calculate the net torque, this sets up a clockwise torque, so we call that distance L2 times the force F. And this one has no torque because it's again going through the pivot, so my total torque is just L/2F. If we look at example E, then what we have is we have a force at the quarter point and a force at the end point, and again my midpoint as the pivot, so this sets up a clockwise torque. This would set up a counterclockwise torque. So my net torque is going to be this distance being L/2 times F. And this distance, which is L/4, so that's a minus because it's a clockwise torque, L/4F. So when I do this, I end up with a total torque of L/4F. And then finally for F, we have a force at 3/4 and a force at the end point, and here's the pivot again. So both of these are setting up counterclockwise torques. So my net torque, this distance is L over 4. It's going to be, for the first one, L over 4 times F. And then this distance for the second one is going to be, so it's going to be plus because it's also a counterclockwise torque, L over 2 times F. So my total is like 3L over 4 F. So that means that if we look at the size of each one of these, my ranking is going to be F is certainly the largest net torque. And then we have D, which has L over 2F. And then C and E are tied for L over 4 times F. And then A and B were both 0. And notice all my torques are positive, so none of these set up a net clockwise rotation. They're all counterclockwise rotations. So my net torque, or this would be the ranking for this particular problem.